Okay, hey everyone. So jumping right back in, we're going to talk about recognizing transformations. You need to know linear, quadratic, and absolute value. Now linear, I know we didn't really talk about them, but as soon as you start applying slopes and things like that, you're changing things whether or not you give yourself credit for doing it or not. So right off the bat, if you think about this being your parent function, okay, so that's a parent function of a linear function. Automatically, we moved up 4 because instead of it hitting at 0, 0, now it's hitting at 4. So you could say that this is moving up 4. Also, we went from having a positive slope to having a negative slope. So that means we had a reflection. Now, reflection, which direction is really, really hard to tell, especially off of a line. So when in doubt, you're always going to say that reflection over our x-axis, okay? And then the last thing, it went from being a little bit steeper to now it's a little bit more shallow. So if you see, we're going down 1 and we're going over 1, 2. So instead of our slope being 1, now our slope is half. So if it's a half, that means it's a vertical compression by 1/2. So again, it's kind of weird to think about linears having transformations, but in this case, this one has 3. So you can see what those 3 are. So if we came over here and we looked at the equation for a linear, all right, this slope, again, is telling us that instead of having this line, it's going to be a lot steeper of a line. So we're going to say that this is a vertical stretch by 2. And this one just happened, again, this +4 is all the way at the end. It's not in parentheses with the x. Okay, so if it's not in parentheses, that's up and down. So this is going to move us up 4. I doubt you're going to see something like that, but if you do, now you've seen it and now you can rock it. Okay, then we're going to talk about absolute value. We talked about this a lot, and if I had to say something I think you guys are fantastic at, I would say you guys are fantastic at this. So first of all, always checking to see, is anything getting reflected? So in this case, this is not reflected because your parent function looks like this. Okay, so it follows the same shape, no reflection. It did move though. So if we look, it moved up 2 and it left 1. So we're going to say up 2. We're going to say left 1. And then we're going to check to see if anything happened with that slope. Again, slope's up 1 over 1, up 1 over 1. This is up 1 over 1, up 1 over 1, up 1 over 1. So no stretch, no compression, no anything like that. So just these two happen on that one. If we move over here to this equation, all right, you have an A value, you have an H value, and you have a K value. So we have 3 things that are happening. 6 is telling us that that's going to be a vertical stretch by 6. Any number that is greater than 1, always going to be a stretch. Any of your fractional 1/2, 1/3, 1/6, anything like that, 3/4, any fraction that's less than 1, that's always going to be your vertical compression. +2, we always think about opposite when we're hanging out in those absolute value bars. So this is going to move us left 2, and this -7 at the end is going to move us down 7. All right. So next one we're going to look at is we are going to come and we're going to look at some quadratics. So again, I got you a graph, I got you an equation, so you can look at both. So first of all, automatically, our normal shape is like this. So this is flipped over. And when you're thinking which way it flipped, it went from this way and it flipped over that way. Okay, so that is going to be a reflection. Now, if you are not specific, you're going to lose points. So reflection over the x-axis. That's what turns it over. If you reflected over the y-axis, you would take this U shape like this, and you would flip it over. It would still just be a U shape. All right? It wouldn't look like anything changed. So it can't be that one. It went left 2 because our new vertex is up here. So we're going to say that it went left 2. It also went up 4. And now the easiest one to think is on your parent function, and I did a horrible job drawing this parent function, but your parent function should go up 1 over 1 to hit the next point in your quadratic. This one does that. It goes down 1 over 1, down 1 over 1. So there's no kind of stretch or compression that happens on that one. So it's just those 3 things that are happening. This next one also has 3, so this negative in front is telling us that it's going to be a reflection over the x-axis, because if something's happening to the y's, that means it has to go over the x-axis, because if it goes over the y-axis, the y's didn't change, but if it goes over the x-axis, it goes from being positive, flips down to being negative. Plus 1 is moving us left 1, and minus 5 is going to move us down 5. So that hits those three different transformations there. Again, if you need help with that, make sure you're coming in to ask for help. The next part is kind of the big part. So this is the one, it's going to be the next video. Compositions was probably the thing I think we struggled with the most. And so just make sure you guys are coming back so I can really work through these a little bit slower than maybe we did in class the first time, and you can get a little bit extra practice. All right, see you in the next video. Bye.